Hey, in this video, I'm trying to analyze the different market trends related to artificial intelligence, either from an investment perspective, but also from a technological standpoint. If this sounds interesting, feel free to drop a like, a comment, or share it with people that might be interested into the topic as well. We are entering 2026, and here's a figure that will surprise you. More than half of the global investments in venture capital goes toward AI, and this is just the beginning. 30% of this investment goes toward AI startups, and still, investors qualify their appetite as insatiable. And this is far different from the previous bubbles. Mark Anderson, which is the founder of Netscape and also A16Z, a venture capital firm, qualify the AI revolution as economically more impactful than the internet itself. And this is shown by the adoption rates that have no comparison in historical data. And what is even more impressive is that only a few regions of the world are investing into the massive AI, mainly China, US, Europe, and also the UAE. But why is this concentration? This is because the key technical players in the world are trying to win the AI race. And this is why in 2026, we could expect the biggest funding rounds that ever existed. AI is evolving faster than the Industrial Revolution. But here's what few people realize. They follow the same pattern. Every technological revolution followed this immutable pattern. First, disruption, then transformation. The Industrial Revolution, a 5 to 15% decline in labor's share of income spread over decades. But here's the crucial difference. With AI, this timeline is now compressed into just a few years because of the cloud infrastructure and the improvements in compute. And unlike in the 19th century, a loss of share does not necessarily mean a loss of human jobs. The numbers speak for themselves. New AI companies like Lovable, Cursor are growing revenue at an unprecedented rate. And here's what's happening now. 2026 marks a new phase of the AI industrial revolution. Some sectors will explode, others will disappear. The question is no longer if, but who will survive this transformation. TSMC, you might not know this name, but this Taiwanese company literally manufactures all the chips that power AI globally. In 1 year, the company saw an increase in revenue of 20.45%. But here's what few people realize. TSMC cannot manufacture anything without this European company, ASML. This Dutch company provides the only machines in the world capable of etching the finest circuits on the planet. The duo is indispensable. ASML creates the machine, TSMC produces the chips. NVIDIA, AMD, Apple, they all depend on this Taiwan Netherlands chain. No alternative exists. And here's why this is a major geopolitical issue. Taiwan produces 92% of the most advanced chips, and China claims the island. If a conflict breaks out tomorrow, the whole AI economy would collapse. That's why Taiwan is said to have a silicon shield, because the entire world has an interest in protecting the small island. Because without TSMC relying on the different machines of ASML, the global economy would take a major hit. 2026, the year when the AI chip market could experience a major revolution. Google and NVIDIA are vying for dominance, with on one side NVIDIA's GPU and on the other Google TPUs. But why are these chips so important? Every artificial intelligence model requires intensive training, and this is where GPU come into play. Their architecture allows for massive matrix computation, an essential element for AI training. But that's not all. Chips must also provide ultra-fast connectivity as well as humans' memory to process large amounts of data in real time. This is what makes them irreplaceable for model training. And here's the key. Training deeper and deeper neural networks require exponential computing power, and GPUs and TPUs are especially tailored for this. And that's why in 2026, we could expect to see an increase in the usage of these chips in global data centers. So why is this so important? Because these AI chips determine the velocity and the speed at which these AI models learn and evolve. And in a world where the technological competitiveness is crucial, it is becoming a major strategic issue to master these techniques. Training an AI model is one thing, but do you know what costs money? Making it available to millions of people after training. And here's a figure that reveals everything. Google Cloud shows $106 billion in pending orders thanks to AI. Their TPUs no longer just serve training, they start attacking the inference market. And here's what NVIDIA refuses to accept: losing this battle. The counterattack? 20 billion. NVIDIA just invested in Grok, a startup that develops AI inference chips that are 10 times faster than classic GPUs in order to benefit from their technology. And this is one of the most massive investments in the history of the sector. Why this frenzied race to inference? Because that's where profitability is at stake. Every second saved on a model query could mean millions of euros saved on a global infrastructure. And while the giant fights, a French startup like Arago is trying to develop photonic processors in order to decrease by 10x the energy consumption of these chips. Because in the chips war, the next battlefield could be the energy efficiency. 600 billion. That's what hyperscalers will invest in 2026 in their data centers, a staggering 36% explosion in 1 year. Do you know why these numbers defy all traditional economic logic? Training an LLM requires thousands of interconnected GPU that must communicate in real time. Imagine orchestrating 100,000 machines at the same time. That is exactly the challenge that AWS, Meta, Microsoft, and Google are tackling in their new training facilities for large language models. Take the Stargate project. 500 billion invested over 4 years for OpenAI and Oracle. OpenAI expect to deploy 10 gigawatts of power in the future. This is the equivalent of 10 nuclear plants dedicated solely to training machines. Why this insane race for gigawatts and compute? Because every second of training lost costs millions. Chip-to-chip connection should be perfect, latency should be non-existent, and a single GPU failure could paralyze the whole cluster and cost several millions. The result? 75% of the 600 billion invested in 2026 are specifically targeting the AI infrastructure. We are witnessing the construction of the most expensive technological infrastructure, and this is just the beginning. What happens when a company can't invest billions into training its own AI? Last year, DeepSeek claimed to have developed a model rivaling with GPT-4 for only a fraction of its cost, $5.6 million, compared to potentially $100 million for training GPT-4. But how did they do that? Their innovation lies in using a mixture of expert architecture that allow a large model to only use a subset of its parameter in order to produce a response. This means that over the 671 billion parameters of the model, only 37 billion parameters are activated in order to produce a response. This intelligent delimitation offers a few advantages, both from the inference standpoint, but also the training perspective. Rather than training the full model at each step, we could only train 5.5% of this model at each specific task. The result, a model distributed across several GPUs that leverage this parcellation. Using fewer neurons per query makes the system way more optimal and efficient. The real revolution? DeepSeek demonstrates that intelligent architecture can rival massive investment and chip shortage. Also, the different optimization techniques that they've created have influenced a lot the different AI model makers during 2025. How does a startup go from 0 to 10 billion in revenue in just a few months? Mercor, which is a company specialized in data annotation, just announced that they reached 500 million in annualized revenue as early as September 2025. Scale AI, which is another data annotation firm, is leading the way with a 29 billion valuation after an acquisition of 49% of the capital per Meta. All these companies have understood a fundamental truth. When models reach their technical limits, data quality becomes the differentiator. Look at the numbers. The global AI annotation market is said to be around $10 billion per year, and companies like OpenAI and Anthropic are now spending a lot on this domain in order to get the best human labeling possible. Why this explosion? Because scaling laws are reaching their limits. Multiplying parameters of the model is no longer enough. Now you need perfectly labelized, contextualized, and diversified data. And the main limiting factor right now is annotation. The message is clear. In this AI race, data becomes the new oil, and companies that will master this value chain will build the foundation of the future of the AI ecosystem. December 2025, Meta acquired Manus AI for $2 billion. This acquisition reveals a fascinating trend. Even the giants who build the best model in the world are diving into tooling in order to democratize the technology's usage. How do you transform a research AI model into a business solution? This is one of the key challenges that some companies like Longchain or Crew.ai are trying to solve. They try to provide better abstraction that makes it easier for people and companies to integrate the technology. This allows some companies without PhD in machine learning to integrate the technology. Other companies have followed this logic. For example, Pinecone, Weaviate are trying to make it easier to access vector databases. They try to provide APIs and abstraction that are way easier than before, allowing non-specialists to use this technology as well. Even companies like OpenAI, Mistral, and Ubiquagent have understood creating the perfect model isn't enough. You need simple API, intuitive interface, connectors, and a way to diffuse the technology in the businesses. The revolution, all these tooling companies are making it possible to transfer the technology from the state of research into usable product. Today, an SME could integrate the technology that yesterday belonged only to research labs. Innovation is shifting from research toward practical applications. 500 million in recurring revenue by May 2025. That's what Cursor did in just 8 months after passing their first million. How do companies explode like this? The answer comes down to one word: distribution. Cursor positioned itself in development, Lovable in no-code. These companies are not developing AI models. They are bringing these models to specific markets. Result, they are able to capture directly the value built by the different AI research labs with their models. This trend is exploding. Enterprise AI reaches $37 billion, up from $11.5 billion in 2024. Vertical AI has tripled this number to $3.5 billion, healthcare reaches $1.5 billion, and legal $600 million. Aging sectors are becoming gold mines. Why does this strategy work? Menlo Ventures reveals that AI startups now capture 63% of the application market, whereas it was 36% the previous year. A doctor doesn't buy a general AI, they buy a solution for their diagnostics. The lesson? Tomorrow's champion no longer build models, they deploy them where no one else looks. Distribution beats innovation, and choosing an aging sector could be the winning bet for the new ventures.